Okay, section 3, we're going to go down to the surface of Venus. You're going to see some oddly colored pictures in this section. If you take a look at the upper right there, you see these kind of orangish pictures. That's not the real color of Venus. That's from some computers in the early 90s that were processing radar from the Magellan spacecraft. So anytime you see that, just keep in mind, that's not at all real color. It was based on what are called radar graphs. And based on those radar graphs from the spaceship Magellan, there are two areas of the planet that are raised up and which you might call continents. They only make up 8% of the total surface versus the 25% that make up our Earth's continents. Of course, there are no oceans on Venus, but there might have been at one time, which is interesting to think about. We just don't know that, actually. But anyway, we're going to take a closer look at the two continents, so-called continents. The first one, Ishtar, Terra. Now, where do they get a name like Ishtar? Well, that was the Babylonian equivalent of Venus, so the goddess of beauty for the Babylonians. Ishtar, Terra is located way up south. Remember, because Venus has a retrograde spin, south is at the top of the maps that I show you, so keep that in mind. It's kind of tricky. This is the smaller of the continents, only the size of Australia, but it has the highest mountains on Venus, the Maxwell Mountains. Now they list the highest peak as 14 kilometers, which seems super high, but remember, we measure our mountains from sea level. There is no sea level on a planet without seas. So it's not really a fair fight. To make it fair, you'd have to measure our mountains from the bottom of the Marianas Trench, let's say, from the bottom of the Pacific Ocean, in which case Mount Everest suddenly doubles, essentially, in height. So to make it a fair fight, that would make Mount Everest at 20 kilometers if you're doing a fair comparison there. So the point is, the Maxwell Mountains are some really tall mountains, and the tallest mountains on Venus. There are some craters, not a whole lot of craters, certainly nothing compared to the Moon or Mercury, but there are some craters we've seen, Cleopatra and Sacagawea. And mentioning those for a moment, it's kind of cool that every feature on Venus is named after a woman. There's only one exception, actually, on the entire planet. I don't know how this came about, actually, but the Maxwell Mountains, named after the famous physicist James Clerk Maxwell from the 1800s. So I don't know how that ended up happening, but everything else named after women on Venus. Okay, let's take a look here at a flat map of Venus, and you see, there it is. There's Ishtar, Terra. Now, Ishtar, Terra is actually not as big as it appears. Just like a flat map of the Earth makes, let's say Greenland look absolutely huge, right? The way it works out. So just keep that in mind when you're looking at a map like this. And that red right there they are, the Maxwell Mountains. Now down here around the equator, you have the other so-called continent, which is named after the Greek version of Venus, who you probably know, the Greek version being Aphrodite. And you can actually see even here on this map, these long, they look like rivers. So we'll take a closer look at those in just a second. Oh, here we go. But those, of course, are not rivers of water. They are rivers of lava. And I mean currently, they can be rivers of lava. We know that there are a lot of active volcanoes on Venus, which is pretty cool. It's the only planet other than Earth that can say that. Planet. There are moons, of course, with active volcanoes as well. But anyway, Aphrodite, Terra, size of Africa at the equator, and so forth, and it has a lot of those kind of long lava rivers. Okay, so what about those volcanoes? I said it's an active planet. Well, they're what we call shield volcanoes, meaning they have popped up in sort of random spots. As you probably know, Earth's volcanoes are anything but random in their location. You've probably heard of the famous Ring of Fire around the Pacific, where most of our volcanoes are located. Now, we do have shield volcanoes as well, as I'll show you on the next page. But everywhere, since Venus does not have plate tectonics, which is why we have the Ring of Fire, of course, the big Pacific plate rubbing up against other plates. since Venus doesn't have plate tectonics, well then of course, you don't have anything like that. So all volcanoes on Venus are considered to be shield volcanoes, Sif Mons, Gula Mons, Mat Mons, and so forth. I'll show you some radar pictures of them. And oh, here we go. Here's some radar pictures. Again, not true color or anything, all based on bouncing radar and getting the topography of the planet back in the 90s, I believe. Gula's kind of interesting there, isn't it? Reminds me of Devil's Tower in Wyoming, perhaps. All right. That was just an interesting looking crater there. All right, so there is the aforementioned Ring of Fire and all those little triangles there where Earth's volcanoes are located. Some famous ones there, Mount Fuji, of course, in Japan. Mount St. Helens, which erupted when I was just a little kid. I remember that well. Now, what are the shield volcanoes on Earth? Well, the Hawaiian Islands are a great example because look at that. They're right in the center of the plate. So the Hawaiian Islands were created in kind of a hot spot in the middle of the plate. So that makes them shield volcanoes. And just, I didn't know where else to put this word, but one term that we'll use with volcanoes sometimes is caldera, which is just the top rim of the volcano. In the lower left is one of those little red triangles right in here. That's a picture that I took at Arenal in Costa Rica, which is one of my favorite places to visit. And I've been there before when there's actually active lava, flowing down the side, which looks really cool at night. I've also been there when, we've had earthquakes and things as well. So it's a very active region in that sense. Okay. So, why are there few craters? I mentioned there are some, but not many. Well, two reasons. You can probably guess. One, you have this super thick atmosphere, so it's not like the moon where you're going to get a bunch of small craters. And then, of course, you have a repavement going on. You have active lava flows everywhere. So it is considered to be a very, very young surface. Venus has a very young surface. Now, I keep saying it has active volcanoes. We don't actually have any video of that happening. So how do we know that? Well, there's some really solid evidence that they're currently active volcanoes. For one, you get these fluctuations in sulfur dioxide. So if there's a spike in sulfur dioxide, what else is that going to be? That's pretty obviously a volcano. And then the other thing that I think is really fascinating is that you actually get radio signals when a volcano erupts. Now, how are those things connected, right? That seems really strange. Well, it turns out, and I didn't know this, that the plume of a volcano will actually trigger lightning. And the more I investigated this, the more fascinated I became. Look at some of the pictures I found just here on Earth of this phenomenon. So here's an active volcano in Hawaii, and you just see right in the plume there these lightning bolts, and that sends out a radio signal. So the volcano creates a plume, the plume triggers lightning, kind of like static electricity, and then that sends out a radio signal. So when we get radio signals from Venus, we know that there's a volcano erupting. But that's just one. That's in Hawaii. Now check these out. This was the famous eruption back in 2010 that a whole bunch of flights out of Europe got canceled and diverted. Look at this. Just amazing, amazing pictures of this massive volcano erupting. These were from National Geographic, I believe. Can you imagine being in the airplane while they were filming that? It looks like something out of Lord of the Rings or something. It's just unreal. Some of the favorite pictures of Earth I have ever seen. Some of the most dazzling, just unbelievable pictures. Again, I'd be scared to death if I was flying through that, let me tell you. So that was in Iceland back in 2010. Here's one in Japan in 2011 showing the same thing. Anyway, I just had to share a few of these. I couldn't stop because they're just absolutely amazing. So finally, let's talk about the actual surface. Let me just mention that the United States has never landed on the surface of Venus. We've never landed, even, of course, an unmanned probe. The Soviets have, but boy, they had a tough time of it. They were losing spaceship after spaceship after spaceship back in the 70s, and finally, Venera 9 and 10. So they knew it must be a rough place because they were not hearing from these spacecraft. And finally, Venera 9 and 10 landed, and they only lasted about an hour. Yeah, now why is that? Well, as we mentioned, it's, first of all, it's 850 degrees there. That's one. Secondly, if you were to land, because of that super thick atmosphere, the atmospheric pressure is huge. It's kind of like when you swim to the bottom of a pool and you have that weight on you. If you were to land a regular airplane on Venus, it would just crumple it up like you're crumpling up an aluminum can. Okay, so there's tremendous pressure. Oh, and did I mention we think that it rains sulfuric acid? Yeah, it's a rough place. It is a really rough place, and the Soviets found that out the hard way back in the 70s, and they never went back, and the United States just said, forget it, we're not going to land there. So that's one reason I'm not terribly interested in Venus, because, of course, it's not a place that we think of to look for life. It's not impossible. Not impossible. You could have microbes up in the atmosphere or something. But finally, what did the Soviets get for their money and effort and time? This picture right here. That's it. That's pretty much the only picture they got back. Looking straight down at the bottom of the spacecraft, you see one of the landing gears here. You see a random piece of it that fell off here. And all you see are some flat rocks and so forth. Now, a few years ago, a NASA scientist took these original images and cleaned them up and actually was able to extract more information to get this, which is quite a bit better. And you can kind of get a much better feel for what it would be like to stand on Venus. Of course, it's going to be totally cloudy every day. And you're really not going to have much color for that reason. It's just basically a very overcast day every day and super, super hot and a lot of pressure and yeah, and possibly sulfuric acid rain. So it is a hellish place. And, that's why you don't hear about a lot of, that's why we're sending rovers to Mars and, not to Venus. Let's put it that way. So a couple more pictures there from, Venera missions back in the 70s. And that's it for the surface of Venus. Thanks for listening.